12, 6. Excellent. So, but more importantly, that means my function, f of x, can be written as x plus 4 plus 6 over x minus 3. Here's a really quick rundown of why slant asymptotes work. When x gets really, really big, what happens to the fraction 6 over x minus 3? It gets very small. I put a huge number in for x, I get a huge denominator. Which means, if you look at this problem from very far away, like if you have a scale on your calculator where x goes out to like 10,000, this might as well not even be there.
So you can just like...
Yeah, you can just pretend the function is like x plus 4. You just forget about it. In fact, if you said, hey, give me an estimate of the value of this function when x is 10 million, my estimate is going to be that 10 million and 4. I'm not even going to bother to plug 10 million into this.
Right.
I'm just going to say, you know what, at that point, it's close enough. So that's why the slant asymptote works. Okay? Now from this up here, I know that it has x-intercepts at -3, 0 and 2, 0. Is that correct? If I put in 0 for x, I get -6 over -3. So I know it has a y-intercept of 0, 2. Is that correct?
Yeah.
Yep, put in zeros, it all goes away. That's positive 2. Good. Slant asymptote we did. Vertical asymptote is at... Vertical asymptote is at x equals 3. Okay, here's the fun one from this, my quick sine chart. This is everybody's favorite part, right?
Yeah.
Martina, I love it. All right, x minus 3. Okay. -3 is the interesting point on this factor. Positive 2 is the interesting point on this factor. Positive 3 is the interesting point on this last one. Negative, 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 0, plus, 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 plus. I love it. And by the time I do this, I feel like I'm too uncoordinated to make a plus sign when I get over to the end. Negative, 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 0, plus, 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 plus. Negative, 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 0, plus, 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 plus. And then I need one for the whole function. I need to put all my interesting points on it.
Negative, positive.
Okay. Negative divided by a negative is a positive divided by a negative is? Negative. 0 on the top is?
Yeah.
0. Okay. Positive times a negative divided by a negative?
Negative.
Positive.
Oh, you wrong.
Let's see, that 2 is still on the top. 0. Positive divided by positive divided by negative. 0 on the bottom is?
0.
Asymptote.
What?
Positive divided by times positive divided by positive is positive.
Gotcha.
True.
Knee slapper.
You. I slapped my knee at you. Okay. James, follow me over here for the graphing. Okay. Ready to graph this thing?
Yeah.
Not at all.
Woohoo.
It must be so much easier to graph it there.
Not really.
It actually is a little bit. It is for me now. It wasn't at first.
What?
Okay. To graph a slant asymptote, you must remember how to graph a line. How do I graph the line x plus 4? Well,
Start at 4 and you go sideways.
start at 4 and I go up 1 over 1. That's a slope of 1. I'm not sure what you meant by sideways.
When you take your book, you go like that. You go 1 over 1, you go 1 up, 1 over 1 up.
Yes. So there's my slant asymptote. Now slant asymptotes, like horizontal asymptotes, can be crossed near the origin. The function can cross them. Vertical asymptotes can never be crossed. Function cannot exist there. So there's that vertical asymptote. Y-intercept of 0, 2 is right there. X-intercepts at... I put my asymptote in the wrong place and no one corrected me.
I was
You say what?
looking at my book.
Wait a minute. How did we get the asymptote again?
Synthetic division. Synthetic division.
Ah,
How you go 1 over? Yeah, how you go 1 over 4? Well, 1 4 over 1.
right there.
X plus 4. I'm just graphing the line X plus 4.
Oh, okay.
I got the line X plus 4 from my remainder of 6 for my synthetic division over here. So then I make that a dotted line since it's an asymptote. I got the vertical asymptote in the right place. I've got my 0 there and there. Okay, now.
You're missing one.
And I've got, yes, I do, I'm missing one, over here at 2. Okay. F of x has got to start out negative, hit the 0 at -3, then go positive. Okay, so for it to snuggle up to this asymptote and then hit this point, I'm thinking it's got to start out doing something like that. Does that make sense?
Yeah.
Okay. From here, it's just got to get to its y-intercept. That's easy enough. Then from here, it's just got to get to its x-intercept. And then from here, it is supposed to be negative while snuggling up to this vertical asymptote. This part, it's got to be positive and snuggle up to both these asymptotes. I didn't leave enough room to do this as well as I would like, but in order for this function to always be positive and snuggle up to both of these things, it's got to be doing something like this up here. Can you guys see that shape?
Like
Yeah.
a U.
Like a U. It's like a sideways U, like an italic U. And if you graph this on your calculator and zoom out enough, just keep hitting zoom out, this part here in the middle will start to get, you'll lose it because of the resolution, and it'll look just like the line y equals x plus 4. But I'm not going to ask you to do it that zoomed out. Questions, comments, concerns, compliments?
Have a good weekend.
Okay, we're done. You can cut it.
I'm amazing.
So
Okay.
amazing.